Hello and welcome back to another video of GMAT Friday. I am Abhishek Dey, your quant mentor at IMS International. In this series, every Friday we delve into a question from either quantitative reasoning, verbal reasoning, or data insights. If you haven't already seen the previous questions, click on the I button to catch up our previous videos. Today, we are diving into a question from the quant section. I encourage you to pause this video, attempt the question, and resume to see the solution. Let's look at the question first. How many positive factors of this number are perfect squares which are greater than 1? Fine. Let's start with factors. A is said to be a factor of B if A divides B completely. If I ask you, what are the factors of 10? The answer would be 1, 2, 5 and 10. If I ask you, what are the factors for 20? 1, 2, 4, 5, 10 and 20. That means 10 has a total of 4 factors and 20 has a total of 6 factors. If I go ahead and ask you, what are the total number of factors that 200 have? I am definitely sure you're not going to calculate this and not going to write all the factors and then count them and then tell me. There must be an easier way to solve this. Whenever you're asked to find total number of factors or any factor related questions, the very first thing that should come to your mind is prime factorization. Let's start. So the prime factorization of 200 is going to look like this, and again a 2, and a 5, and then one more 5. That means I can write 200 as 2 raised to the power 3 and 5 raised to the power 2. Can I say that the highest power of 2 that can divide 200 is 3 and the highest power of 5 that can divide 200 is 2? That means any power of 2 that is less than 3 can divide 200. Can I say that 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2 and 2 raised to the power 3 are the four powers of 2 that can divide 200? And at the same time, 5 raised to the power 1, 5 raised to the power 0 and 5 raised to the power 2 are the 3 powers of 5 which can divide 200. Or a combination of these two columns can also divide 200. That means 2 raised to the power 0, 5 raised to the power 0, 2 raised to the power 0 times 5 raised to the power 1, 2 raised to the power 0 times 5 raised to the power 2 are the 3 again factors of 200. Similarly, I can have 4, 5 and 6, 7, 8 and 9, 10, 11 and 12. That means I have a total of 12 factors of 200. Yes or no? So what I actually did is I just multiplied the number of options that I had in each of the columns. Yes or no? Now, can I say that I just added 1 to each of the powers and multiplied it? You don't need to write this thing every time. Okay, you just have to add 1 to each of the powers of the prime and multiply the resultant, and you will get the answer. Clear? Now, try one. Try to find the number of factors of 2 raised to the power 7 times 3 raised to the power 6 times 5 raised to the power 4. Give it a try. Comment down the answer. Okay, let's move to the question now. 2 raised to the power 4, 3 raised to the power 5 and 10 raised to the power 4. In the beginning, I asked you to go ahead with the prime factorization. Is it the correct form or the correct prime factorization of the number? No, it has a composite number. The composite number is 10. So let's find the correct prime factorization of this number. So 2 raised to the power 4 is perfect. Then we have 3 raised to the power 5. And then we have a 10. 10 can be written as 2 times 5. So I can go ahead with 2 times 5 whole raised to the power 4. So 2 raised to the power 4, 3 raised to the power 5, and then again a 2 raised to the power 4 times 5 raised to the power 4. If I take all the like terms together, I'll be left with 2 raised to the power 8, 3 raised to the power 5, and 5 raised to the power 4. What are the total number of factors that I can get for this number? I just need to add 1 to each of the powers and then multiply them. That is going to be 8 plus 1 is 9, 5 times 1 is 6, and 4 times 1 is 5. So 9 times 6 times 5. 6 times 5 is 30 times 9 is 270. So a total the 270 are the total number of factors that this number has. Now, I was asked to find the perfect squares, the factors, positive factors which are perfect square and greater than 1. Can I say that 2 raised to the power 0, 2 raised to the power 2, 2 raised to the power 4, 2 raised to the power 6 and 2 raised to the power 8 are the only powers of 2 which can help you get a perfect square? 2 raised to the power 1 will never help you get a perfect square. 2 raised to the power 3, 2 raised to the power 5 and so on, all odd powers of the prime factors are not going to help you to get a perfect square. So that means I am left with 3 raised to the power 0, 3 raised to the power 2 and 3 raised to the power 4 if I talk about the powers of 3. And similarly 5 raised to the power 0, 5 raised to the power 2 and 5 raised to the power 4 if I talk about all the powers of 5 which will help us to get the perfect square. As I did in the last question, we can again go ahead with just multiplying all the terms that I have in each of the columns. So I have a total of 1, 2, 3, 4 and 5 terms in first column, then 3 terms in the second column and again 3 terms in the third column. That makes a total of 45. That means I have a total of 45 perfect squares which are a factor of this particular number. There was one more clause in this question, that is the perfect squares should be greater than 1. And 2 raised to the power 0 times 3 raised to the power 0 times 5 raised to the power 0 will give me 1. So I have to exclude this particular factor. That means I have a total of 44 perfect squares which are positive factors of this particular number. I hope you get this answer. If yes, please try this question. Try to find all the odd factors of this particular number. If you find this video helpful, don't forget to share it with your friends, like it and subscribe for more such updates. Till then, bye-bye.